Hello guys, so today we'll be going to study a topic that named as outliers. You might have heard from many people that when they're working on the data set, they say that the data have outliers in it. So today we'll be learning that what are outliers, how they come in a data, how we can work over the data that have outliers and how we can remove it. And the data that have outliers, how it create various type of problems. So come and study this video. Outliers, so when we're coming to this topic of outlier, the first thing comes in our mind that what are outliers and how we can work on it. So the point is, by seeing this image, what comes in your mind? That is, can you find something odd one out from this image? I think if you will be checking this image clearly, then you can find that a person standing with red jacket is a one which is a odd one from this number of kids from this data. So if you can directly view from the data and you can find the odd one from this data, you can reach to a perspective of finding the outlier. So if we are saying it in a definition manner, a outlier is a data point that differs significantly from other observations. So we can say these are the observations and the one which is differs significantly from these all will be called as an outlier. Hence, the person in red jacket will be outlier in this image. Now, the point what does differ significantly mean? As in the previous slide, we have seen that we have mentioned differ significantly. That with the help of a word differ significantly, we can find the outliers from the given sample. Now, what does differ significantly mean? So, the answer is that data points that are out of the range will be called as the points that are having outliers. So the the word comes here is range, and the range will be not defining it with the maximum to minimum value, will be defining it with the word which is called as IQR. In the later video, in the later slides, you can see that what does IQR mean. So the example we are taking here of a data is that we have this given data sample of a data which will be having the values 10, 11, 15, 17, 13, 18, 14 and 52. You can see that this data is not in a sorted manner and have various values inside it. Now we need to check that whether there is any outlier in this data or not. So once we are checking this data and we are keeping in a sorted manner, we found that all this data, that is 10, 11, 12, 13, 14, 15, 17, 18 are in one range, whereas the data that differs from it is 52, which is very high bound from this data. Similarly, from this, in this image, all of these are the small kids. But if we are talking about in terms of height and age, we'll be having one person, this person, which will be looking like that this is an outlier and it is an out of range. So when we're talking about the word differ significantly means differ significantly will be defining us that the data which is differ from the other sample of data will be called as an outlier. And when we have a mathematical data, we need to find that differ significantly value with the help of a range keyword, and that range will be called as IQR. So now point comes that how we can detect outliers. Answer is, for detecting outliers, we need to study IQR. As in the previous slide, I have shown you that we need to find range, and the one which is out of our range will be called as a outlier. The range here will be defined with the help of a keyword IQR, which is called as interquartile range. So before going forward, we must be knowing about what is IQR. So IQR is interquartile range, is the range of values between quartile 1 and quartile 3, and we can find it with the help of the formula IQR is equals to Q3 minus Q1. But for studying and for detecting outliers, you must be knowing some basic terms. That is, you must be knowing about the word quarters. For example, if we have a given a data and that data have a total number of rows and we are taking all that rows in a sample of 100%, then if we divide that data in 4 partitions, and then 4 partitions will be called as a 4 quarters, and each will be having 25% of data. Similarly, like a cake, if you are dividing a cake among 4 quarters, every quarter will be having an equal size, then the 4 are called as 4 quarters and will be having 25% of data. Similarly, we are saying that if we have a big data and we are taking it in 100%, and if we divide that total data among 4 quarters, every quarter will be having 25% of data, and we say it basically a word with a quarter. Now, for dividing the data into quarters, first of all, we need to sort the data in a ascending order. So for finding IQR, we must be knowing that what are quarters, and we must be having the data in a sorted manner. Now, if we're talking about the data in a sorted manner and for creating the quarters, then the first thing that we'll be having always the minimum value. Data will be starting from the minimum value that will be called as a least value in a data set. After minimum value, we'll be reaching toward the 25% of the data. And when we'll be moving to 25% of the data, the 25th value will be called as a quartile 1. So data after sorting in ascending order, the least value lies in this quarter. So the values between minimum value to quartile 1 will be coming under the quarter 1. Then quartile 2, the data value between quartile 1 to quartile 2, that is a median value of our data, will be coming under quarter 2. And similarly, we have quartile 3, which will be lying at the 75% of the data, or you can say the 75th value of the data will be quartile 3. So between 50th value and 75th value of the data, the quarter is called as quarter 3. Similarly, the maximum value is the last value in a data, and the quarter between quartile 3 and maximum value will be taken as quarter 4. So hence we have 4 quarters, and these 4 quarters are being divided among these values, where the first value is minimum value, then we have quartile 1, then we have quartile 2, then we have quartile 3, and then we have maximum value. If in terms of values, I can say that minimum is my 0th value, whereas quartile 1 is my 25th value. Quartile 2 is my 50th value, or we can say it is the center of the data. Quartile 3 is my 75th value, and that is called third, or we can say third of partition of the data. And the last one is called maximum value, which is, we can say, the 100th value, the last value of the data. Now, if we have any of the data like this in a sorted manner, like 15, 16, 18, 20, 21, 23, 27, 29, 32, and we need to find the quartiles from this data, and we need to find IQR in this data, how we can find it? The first value we have will be called as a minimum value. The second value we will be having as maximum value. The first value is a minimum, the starting one. The last value is the maximum one. Between minimum and maximum, the center value will be taken as median. So median will be the center value out of all these values. You can see before median there are 4 values, after median there are 4 values. So the center value will be taken as a median. Between minimum and median value, it will be taken as quartile 1. And between median and maximum value, it will be taken as quartile 3. And for finding IQR, as we have seen above here, it is mentioned for finding IQR, we require quartile 3 and quartile 1, and quartile 3 minus quartile 1 will be giving us IQR. So here, this region where the values between quartile 3 and quartile 1, these are the values that are lying under the range of IQR. And for finding these values, we can use IQR, that is Q3 minus Q1, and that is 27 minus 18 is equals to 9. So hence the IQR, that is interquartile range, the range of the values between two quartiles, will be moving in the range of 9 values. So you can see that the value that are moving from 18 to 27, the values will be having the variation of 9 values only. So that is called as interquartile range. Now, if we are finding the interquartile range, then with the help of this interquartile range, how we can detect outliers? So for detecting outliers, we have two equations. The first equation says, for finding an outlier, the value should be greater than the interquartile range plus the quartile third value. So what I'm saying is, for if you want to find any of the outlier, that outlier would be your third quartile plus 1.5 into your IQR value, and your outlier can also be lying between the quartile below quartile 1 and minus 1.5 into IQR. The IQR is interquartile range. Now we'll be taking a small example and we'll be solving it, then you will be knowing it clearly. The example is this, that we have some of the values that are not in a sorted manner. So first of all, what we need to do is we need to sort these values. After sorting, we got these values as 10, 11, 13, 14, 15, 17, 18 and 52. Now you can see the minimum value is 10 and the maximum value is 52. The median we'll be getting is the center value that will be between 14 and 15. The first quartile will be getting between 11 and 13 and the third quartile will be getting between 17 and 18. So see it here. The first quartile we'll be getting, that is between 11 and 13, that is quartile 1, and for getting that value we'll be doing 11 plus 3, center of these values is 11 plus 13 divided by 2, so it means it will be 12. Similarly, we'll be having a median between 14 and 15. 14 plus 15 divided by 2 is 14.5 will be our median. That will be also called as quartile 2. Then third is 17 plus 18 divided by 2 will be called as quartile 3 and will be 17.5. So you can easily visualize that how we are finding the quartiles. We are sorting the data. After sorting it, then we are finding the median value. From between median and the minimum, we have two values will be taken as the quartile 1. If they are even in number, then we have to sum both of them and we divide by 2 will be bringing us to the region where we'll be getting a center value of it. Similarly, quarter 2 you have to find, similarly quarter 3 you have to find. Then for finding IQR, what we need to do is Q3 minus Q1. So IQR equals to Q3 minus Q1, which is equals to 17.5 minus 12 equals to 5.5. Hence our quarter 1 is 12, our quarter 3 is 17.5 and our quarter IQR is 5.5. Now if we'll be keeping these values in this equation, we'll be getting to know that in this sample would there is any value which is outlier or not. So for outlier, if any value in given sample is below Q1 minus 1.5 into IQR, where Q1 is 12. So 12 minus 1.5 into IQR is 5.5. So 12 minus 1.5 into 5.5 will be giving us 3.75. What does it mean? It means if my sample have any value below 3.75, then it means that value will be an outlier in my data. Now, for other outliers, there are two equations. The other one is if any value in a given sample is above my Q3 is my 17.5. Any value is above 17.5 plus 1.5 into 5.5, that is 25.75. Any value is greater than 25.75 in my sample would be taken as outlier. And you can see that we have highlighted that this 52 is greater than 25.75. Hence, this value is taken as an outlier. I think you might be getting it, that how we can find a outlier. I can repeat it again. First of all, you need to keep your data in a sorted manner. Then you need to find the quartile 1. Then you need to find the quartile 3. Take a difference between both the values, that is called IQR. Now quartile 3 plus 1.5 into IQR will be telling you whether the value is going above that value. If the value in your data is above that value, will be taken as an outlier. Otherwise all the values will be inside the range and there is no outlier. Now, is there any other way to detect outliers? Yes, there can be the other ways to detect the outliers. So what are these ways? For detecting outliers, we can use the plot which is called as box and whisker plot. You might have heard of it, that we are using box and whisker plots many times for finding the outliers. So we'll be studying that how a box and whisker plot graphically tells us that whether the data have an outlier or not. A box and whisker plot is a method for graphically depicting groups of numerical data through their quartiles. So what it is basically doing, box and whisker plot will be dividing your data into quartiles. It also have a lines that will be extending from the boxes of quartiles, indicating whether the data is outside from the upper or lower quartiles, and the data that is outside from upper or lower quartile will be called as outliers. As this is a box plot, a box and whisker plot, where we can see the center values will be taken as a median, which is mentioned by a red line. You can see it here, that this is a median and this is my minimum value. Left side, it starts from the left side. The left value is minimum value. The right and mole value will be the maximum value. With minimum and quartile 1, there are 25% of the values. So this is my quartile 1. Similarly, this is my quartile 3. And the box is defining us this box plot, the box is defining as the interquartile range. So it will be showing me that this of the data will now never be having a outlier. This is a correct data. So Q3 minus Q1, this is IQR and this is called interquartile range. If in your data, listen it carefully, if in your data there is no outlier, then this end will be your maximum value and this end will be your minimum value. And by chance, if your data have some circles coming in this box and whisker plots, these are called outliers. And if in your data there is any of the outliers either above maximum or below minimum, then at that point of time your minimum maximum, they will not be the exact minimum and maximum according to the data, they will be the required minimum and maximum. For example, if in the previous example we have seen 52 was the highest value, that was the maximum value, but because the data have an outlier, so if I will be creating a box plot of it, the maximum value will be 18 and 52 will be coming as a outlier here. So that 18 will be the required max. By default in data it is not the maximum, but when we'll be creating it according to box and whisker plot, it will be telling us that 18 should be the required maximum and the rest 52 value will be the outlier. So might be you'll be getting that how we can create the box and whisker, see the box and whisker plot, and we can find that which of the values are outliers. So simple values is the one which is showing with the help of a circle outside the minimum and maximum range will be taken as outliers. Now we are studying that how we can, what are outliers, how we can detect them, graphical manner, in a mathematical manner. Then the point arises here, do outliers affect data and analysis? Yes, it do affects. How? Due to an outlier, one can reach to misleading hypothesis and analysis. Moreover, due to outlier, mean deviates to the higher amount, whereas median deviates, also median deviates, but it deviates to a less amount, and due to which problem of skewness also comes in a picture due to the outliers. Now, in my next video in this playlist, you can see there's a video of center of measure of central tendency. In that video, you can see that I have given you a small case study that how outlier in that case study is leading to a problem with a in a gym. So you can, after seeing this video, try to see the next video so that you can be directly getting that how a problem arises in a data if the outlier presents in a data. Okay. Now, so if we are talking about mean and median, that how median and mean deviates with this, we are taking a small example for it. The same data that we have earlier 10, 11, 12, 13, 14, 15, 17, 18 and 52, where we know 52 is an outlier. If we are taking the mean of the data with outlier, mean, we are calculating the mean with outlier, then the mean comes at 18.75. And if I'm taking the mean of the same data without outlier, that is I'm leaving 52 and dividing by 7, then we can see the mean deviates with the outliers. With the outlier it is 18.75, but without outlier it is 14. So mean deviates, it means with a huge value. Now if we're talking about median, median of data with outlier is 14.5, but if we take removing outlier and then we are checking the median, now median lies to 14. So we can see that median deviates only 0.5 units. But if we are talking about mean, it deviates with 4.75 units, where the difference between 0.5 and 4.75 is huge enough. So what does it mean? It means that whenever you are working on a data and you are have that data, in that data you have outliers and you are finding the mean from that data, it means you will be leading to a wrong output, you will be finding a wrong hypothesis from it. Now the point is, we have outliers, we know it will be affecting our data. Now can we handle them? Yes or no? Yes, we can handle them in many ways. So we have this type of a data. The first way to handle it, if you want to work on the data that have outliers and you need to find the measure of central tendency, at that point of time you will not be finding mean. At that point of time you have to find median, because median will be very less deviates due to the outliers. So at that point of time you will be taking the median as a measure of central tendency. Second point, now if you want to work on the data with the outlier, then what you can do is you can remove the outlier value and you can work on the data. That is the way, but this way is called as biased nature of analysis. Why? Because sometimes the data that is that you are removing from it, maybe this data will be giving you a different type of analysis. So what you need to do is you don't need to remove it. Take very in a very less amount of time, less amount of cases we need to do this type of a thing, that will be removing the outlier value. So try it that you will not be removing it, try other methods, but yes, there is a method that we can remove it. So remove the values from data that are outliers. That is, if you want to work on this data set, remove 52 and then work on this data. The other method, that is a good method, instead of removing it, what you can do, you can impute the value of the of your outlier. As outlier is a wrong value, it's a huge value that have been inserted. What you will be doing it, you will be making this value empty, you will be removing this value, and instead of that value you will be inserting a other value. Now that other value can be inserted with the help of mean or with the help of a median. As we know, mean will be leading to a wrong output and mean will be deviates a huge amount. So what we'll be doing it, we'll be filling that value with the help of a median. Now, other method is a more accurate method is what we can do, we can use a regression model or a prediction model and predict the exact value that can be imputed at that place. So what we'll be doing is, instead of removing it, again we are imputing it, and we are imputing it with the predicted value using regression or prediction model. And the next method is, or the method which I like is, impute your outliers with NA, so that whenever in your next step of data cleaning, when you will be cleaning your NA values, at that point of time these values that are outlier will also be imputed with the help of NAs only, and your both of the tasks will be done simultaneously. So try to handle the outliers in this manner, and then you can work on your data very clearly.